All right, so we are starting a brand new unit today. We have looked at these equations. We've looked at expressions, algebraic expressions. Remember, have variables involved. And so we looked at things like this. We know that n, or a letter or a variable, represents a number. And we pretty much just left it at that. We could write them, we could explain what they meant, and if I told you what the letter was, you could plug it in and you could evaluate it or solve or simplify. So now we're going to look at expressions, more specifically equations, so we're adding an equal sign, that can actually be solved. So we're going to start off with some real easy ones and then move to some more difficult ones. We're really going to focus today on the process of solving this. It's not about just getting the answer. In fact, that's one of the least important parts of this right now. This is going to be the very, very beginning, the building blocks to moving towards solving some really, really intense, high-level Algebra 1, ninth grade level equations. Okay, so as we start off here, if you can look at this and tell me what the answer is, that's great, but that's more 5th grade, 6th grade level. Showing the proper work, showing the proper steps, being able to explain why you did what you did, that's what we're really going to focus on, because as we move forward, that's what's going to help us build towards these bigger problems. Just being able to look at it and do something in your head is only going to help you on these really easy problems. As we move forward, it's not going to be able to help you anymore. Okay, so today we're going to focus on solving for the variable. So it says solve each equation. That means we want to find out what does the letter actually equal. So our final answer should say n equals something, and then we get our answer. Okay, so our answer will be here, n equals something. So the equation says n plus 7 equals 14. So some number plus 7 equals 14. So this one's easy on purpose so that you can see the answer ahead of time, and then you can see the process that it takes to get the right answer. That what do you need to show, what do you need to actually go through. As we move down the page and you get more difficult questions, okay, that you're not necessarily going to just be able to do in your head, like number 1, you need to know the process. And as we move into ones that have multiple steps, these are all just one step, then you have to know the process and you have to follow that process. So starting here, we should know that the number that we add 7 to and we get 14 is 7. Our final answer here is going to be 7. But if that is all you have on your paper, you're not going to get any credit for it. This is not about doing it in your head. It's about learning how to do this properly and show the proper work, which for some of you will be a battle because that's not what you like to do. But moving forward, it will not be any credit unless you show the proper work. So this is an equation, and we kind of split an equation down the middle. I'm going to draw a little dotted line. This is something that you can continue to draw moving forward. It's also something that you could also just stop showing at some point. But it splits this perfectly in two. And what's true about an equation is you can actually do anything you want to this side of the equation as long as you do it on this side as well. And it maintains its equality. It's still equal. Here's why that works. If we're going to write an equation that's true, like 10 equals 10, and I decide that I want to just add 2 to this side, and now it's a 12. If I left this side alone, now it says 12 equals 10, right? And that's no longer equal. The equality statement is no longer true. But if I add 2 to the left side and I add 2 to the right side, it now says 12 equals 12. Well, that's still true. So it doesn't matter what I do over here. As long as I do it on this side, it is still an equal statement. I could divide this by 3. If I do it on both sides, I get 4 equals 4. It's still equal. Okay, but if I decide to just minus 1 on this side and times by 3 on this side, now I have a 3 and I have a 12, and that's not equal anymore. Okay, so I can't do different things on both sides, and I can't just do something on one side and not on the other. It's very important to do it on both sides. So what we're working towards here is getting the variable by itself, or isolated. So in the textbook, that's what it's going to say. It's going to say isolate the variable. So it's kind of fancy language, but we know what isolate means, right? If you're isolated, you're by yourself. So we want to get this variable by itself. And when they say by itself, it means on that side of the equal sign. So in our final answer, here's our equal sign. N is isolated by itself. Just an n on that side. N equals and then our answers on the other side. So we need to get this original problem to look like this. So how do we get there? So in order to get n by itself, right now it has some company on the left side. It's got this plus 7. Well, that plus 7 needs to go away for it to be isolated. So what we do in order to quote-unquote undo these problems is we do the reverse of whatever we see. So some of you, when you looked at it, you could say some number plus 7 is 14. And you'd say, well, it's 7. What did you actually do? You did 14 minus 7. You thought backwards. Something plus 7 is 14. So if I work backwards, 14 minus 7, I get the answer. And so that's actually mathematically what we are doing. We are minusing 7 from 14, right? And we need to do it on both sides of the equation. So here's what it looks like. You need to write minus 7 on both sides. And then you literally just subtract straight down. 14 minus 7 is 7. You bring down your equal sign. And on this side, positive 7, minus 7. You can get a 0 and write n plus 0, but when we get 0, they basically cancel. So you can show me that a 7 and a negative 7 or a minus 7 cancel. And so the only thing left over is this n. Once that's the only thing left over, you have an answer. N equals 7, and that's what we have right here. And so that's my answer. Now, how did I know to minus 7? Some of you might have just thought about it. But what we're going to do is we're going to do the opposite of whatever we see going on in this problem. Okay, so if we see n being increased by 7, then we're going to decrease it by 7. On number 2, I see r being multiplied by 3. So I'm going to do the opposite of that. So some number times 3 is 30. You may be able to think of it off the top of your head. But let's work through the problem. If this is my dividing line, it just reminds me that whatever I do on the left, I have to do on the right to keep this equal. And I see 3 times a number. So if I want to think backwards and I want to undo this problem, I need to do the opposite of what I see. So since I see multiplication, I'm going to divide by 3. Some of you might have already figured out the answer is 10. 3 times 10 is 30. So the answer is going to be 10. How do we show the work? So what I actually did was I divided 30 by 3. This was multiplication. To do the reverse or undo it, I divide. So how do I show division? Well, the new way we show division is with a fraction. This is how you must show division. So no division signs. Okay, no divide like that. Okay, we're not doing this anymore. And if I do it on the right side, I have to do it on the left side. So this is what it's going to look like. You're going to show using a fraction that you divided by 3 on both sides. 30 divided by 3 is 10. You bring down the equal sign. And 3 divided by 3 is 1. So you would have a 1r remaining. And there's actually always a 1 in front of this variable. We just don't write it. Okay, it's not necessary. It's assumed that it's there. If you put a 1 in front, it's not incorrect. But basically, these 3's cancel each other out, creating a 1. And then this is my answer, r equals 10. It's been isolated. It's done. So number 3. 2 equals some number divided by 7. So if I'm just going to follow my steps here, I'm going to look at whatever's happening between the variable and the number, and I'm going to reverse it to undo it. So I see n divided by 7, which means to reverse it, I need to times by 7. And here's how we're going to show multiplication. You're going to show multiplication on the side like this. It's the only one we show on the side. And it's just because you're multiplying a fraction times this. Okay, so we never really multiply fractions on top of each other. We do it next to it. So we're timesing by 7. And so I'm going to times by 7 on this side. You could write it underneath, I guess. But we want to be consistent. Since we wrote it on the side over here, we're going to write it on the side over here. So this is the expectation of what the work will look like. So on the left, 7 times 2 is 14. The equal sign comes down. And then over here, you're not actually multiplying 7 times 7. Okay, these are going to cancel because technically this is a 7 over 1. And when you multiply straight across, you're going to have an n times a 7. And you're going to have 7 times 1 is 7. And these two 7s end up dividing and making 1, and they cancel. So basically, this 7 divided by 7 and times by 7, they cancel each other out, which is why we did it in the first place. So that shouldn't be too confusing. We wanted this 7 to go away. So we saw divide by 7. Well, how do I undo divide by 7? I times by 7. Okay, they're opposites, they undo each other, so they cancel. And the only thing left over is n. And this is my final answer. N equals 14. If I went back and plugged it in, okay, this would be the correct answer. 14 divided by 7 equals 2. Okay, it works. So you don't need to show this extra part here. All you need to show is that you times it by 7 and then it canceled. Think about for a second any number. If I took 10 and I times it by 7, I get 70. Well, if I now take that 70 and I divide it by 7, I get 10. I end up right back where I started. So timesing by 7 and then dividing by 7, basically none of this matters anymore. I got back from 10 to 10. Okay, so they cancel each other out. Timesing by 7, dividing by 7. So number 4. Some number minus 5 is 5. So we should know the answer already. But how do we show it? How do we undo this problem? Here's my dividing line. Again, I didn't show it here. You don't have to show it. But it just reminds you to do the same thing to both sides of your equation. And you must show it on both sides. So I'm trying to isolate b. I want it to be completely by itself. I want it to say b equals my answer. Right? And so this minus 5, to get rid of a minus 5, I got to do the opposite, which is plus 5. And I got to do it on both sides. Now, anytime we're adding or subtracting, like we did up here and we're doing here, you need to draw this big equals line underneath of it. That's the work that's expected next year when you're in Math 8 with Ms. Butters. She's going to expect you to do that automatically. And then especially when you get to algebra, they're just going to expect you to show your work like this. So we need to start right now. All right, so 5 plus 5 is 10. Bring down your equal sign. On this side, a minus 5 and a plus 5 cancel each other out. So don't just think 5 and 5. It's a minus 5 and a plus 5. Think of it like a negative 5 and a positive 5. They make 0. They cancel. So that means the only thing remaining on this side is b. I've isolated it. It's completely by itself. So b equals 10 is my final answer. All right, let's run through one more quick one. Let's jump down real quick to number 10. Okay, number 10. Now it starts to look a little confusing. I can't quite do this one in my head, but if I follow my same set of rules, everything's going to work out just fine. So here's my dividing line. I'm going to observe what is going on with the variable. So in this case, 9.1 is being multiplied times r. Anytime they're next to each other, it's multiplication, right? So if I want to undo multiplication, I must divide. So I'm going to divide on both sides of my equation by the same number that's being multiplied. So 9.1 is the number that I want to go away, because I want r by itself. I want it to say r equals my answer. So if I want to get rid of 9.1, I need to divide by 9.1. So that will go away. I'm just going to have an r. And I need to divide by 9.1 over here. Now to do so, feel free to use your calculator. So it's going to be 117.39 divided by 9.1. So it's going to look like this. Equals, and the answer here is 12.9. And if I went back and plugged it in, if I changed r to 12.9, this should be true. So 9.1 times r should equal 117.39. So 9.1 times 12.9 equals 117.39. I know I have the right answer if I substitute it back, and it still makes sense. All right. I want you to try numbers 5, 6, 7, 8, and 9. Not just getting the answer. I'm really not concerned about did you get the right answer. I'm concerned about how does your work look and what was the step that you showed. These are only one step to show. How did you show it? Did you show it on both sides? Okay, I'm going to pause the video here for a second and then I'll put up the answers. I want you to pause the video and try it. Then replay the video so you can check your answers. Once that's done, then you can get to your classwork on the back and see how you do all on your own. Okay, so pause the video. And then, after you've tried all these problems, check your answers. Okay, so here are all the correct answers with the work shown. So number 5, I was adding 61 to x, so I subtracted it on both sides. Number 6 was division, so to get rid of division, I multiplied. I saw multiplication here, and I divided, and so on and so forth. So check your answers.